Today we're going to be once again investigating a couple of different relationships. We are going to be focusing on pressure and volume today. Now, this is one that a lot of people probably have a pretty good guess as to how this relationship will go, but it's nice to get some data and some scientific numbers to go with it. So what we have here is a syringe, and instead of a needle being on the syringe, you can see that there's a cap. So we have a set amount of air inside of the syringe. If you take the cap off, of course, you push it, the volume of air will move. And so what we want to do is try and keep this volume of air constant. So this way, when I put the cap on there, if I try and pressurize it, the minute I take my finger off of the syringe, it's going to go back out again. Okay, so we know that at the pressure that we have in this room, this is the volume that this air wants to contain. Now, when we're reading the syringe, there's a certain couple of things that we look for. You'll notice that the syringe itself has almost like two black lines that are on it, and that's part of the plunger. Now, when we're reading it, what we want to do is we want to read the top part of the line. So if I come over to the camera here, you can see that this is crossing right there. So if I was reading this, it would be 8.2468. This is going to be 8.8. If it was in between the lines here, then maybe it would be 8.9 or something like that. So we're going to be reading to the first decimal place when we're using the syringe. Now, you can see the relationship already. We know that there's a certain amount of air. If I pressurize it, the volume drops. If I lower the pressure, if I take my hand off the bottom, then the volume will go back up. But we need some actual measurements. When I say that I increase the pressure, we don't know how much pressure I actually put on it. So in order to measure it, what we're going to do is we're going to take a bottle, and I am going to place the syringe inside of the bottle, and I'm going to put a cap on it. Now you'll notice that the cap has a bike tire valve on it. And so what I'm going to do is I am going to hook it up to a bike tire or a bike pump, and I'm going to pump it up just like I would a bike tire, and you'll be able to see as we pressurize it that that volume is going to start shrinking. That way I could use a tire gauge, and we can read the actual pressure that we have in the bottle, and we can read the volume of our syringe. So let's go ahead and pause the video. I'm just going to hook it up to a bike pump and pump that up real quick. All right, so we're all hooked up to the bike pump. So now what we're going to do is we're just going to start pressurizing it, and we should see that pressure have an effect on the syringe. So each time I pump it up, the bottle's volume won't change, so that increased pressure is going to push its way onto the syringe. So I think that that's pretty much high enough pressure. So let's go ahead and take a couple of measurements. So let's get closer here. So if we were all going to be reading this, I know it's a little bit tougher to read through that foggy bottle, but when I'm looking at this particular one, it looks like it's in between the lines to me. So 2.2, 2.4, not quite 2.6, so I'm going to go 2.5 on my volume. So we have 2.5 milliliters on my volume, and so now we need a pressure. So the way that we take a pressure is we push the valve up, we push the gauge up against the valve, and the pressure inside the bottle will push out this little stick here, and wherever it stops, that's what we're going to go ahead and read as our pressure inside the bottle. So let's go ahead and get a pressure reading here. So we're just going to push it up against it. Okay, so we got the stick that flew out there. So I'm going to go with about 36.1 on that. Now what we're going to do is we're going to change our volume and our pressure and take some new readings. So what I'm going to do is I'm going to take the gauge, and if you see on the back of the gauge there's a little post there, we could let a little bit of pressure out. So I just changed the pressure, so I should have seen a change in volume. Let's go ahead and take a look. So my new volume. Sorry, moving around. And let's get a new pressure. Let's move on to trial 3. There you go. New reading. Trial 4. Pressure. Trial 5. Trial 6. Maybe we can get one more. Trial 7. Might be getting too low on our pressure gauge though. Let's see where we at. All right, still got it there. get one more. Let's give it a try. See if it'll show up on the gauge. Yes, we got it. Now at this point, if I let any more out of the gauge, odds are it won't show up on the gauge, but we could still get one more measurement because there's something for us to remember. Right now, there's a pressure inside the bottle that's pushing on that syringe, but there's also a second pressure. The atmosphere all around us is also pushing on the bottle. So right now, the pressures that I've been measuring, 36.1 psi, the last one we just read, it's that plus one more thing, the atmosphere. So what I'm going to do is we're going to let all the pressure out of the bottle. Okay, so at this point, there's no pressure left inside, but you'll notice that there's still a volume. So let's go ahead and take this volume here. So for trial 9, we've got that for our volume. Now, what is the pressure that we have in the room? So to answer that, we come over to our barometer. And so we've talked about a barometer. Now this one is a digital barometer and we have it hooked up. So we'll go ahead and record this as the pressure. Keep in mind though that these are not the same units that we had on our scale. So on our tire gauge. So when we look at the tire gauge, you'll notice at the bottom it says PSI. So you guys are going to need to do a conversion. You're going to need to convert the millimeters of mercury into PSI. PSI is not something that we would use in science very often, but I got these at the local auto parts store. And the United States, just like we use feet and inches, well, for pressure we use PSI. But in science, we tend to use atmospheres or millimeters of mercury. So we're going to have to work with those limitations. So if I were you, I would just take this value here and I would convert that into PSI so that you can add it to all of your other measurements. So at this point, you should have all the data you need to answer the questions and make a graph on the lab that I've attached. Good luck, guys.